Hello, everyone, and welcome to our second episode of our webinar series focused on reducing the environmental impact of roads through planning and design. My name is Erin. I am the Business Development Manager here at Softree, as well as your host for the series. Having done episode one, 2 weeks ago, we are really encouraged by the enthusiasm towards this particular subject matter. Now, I'm just going to do a little bit of an introduction and then we'll get into the formal content for today. I just wanted to acknowledge that we have a very global audience in today's live webinar. We have representation from over 50 countries. So I just wanted to say welcome, everyone. Thanks for joining us. Thank you for taking some time in your day. Today's presentation is going to be about 90 minutes and probably going to go a little bit over time. And I also wanted to say a particular thank you to those of you who have either stayed up late or have gotten up very early in order to join us. So we have broken an extremely large topic of reducing the impact of roads into 4 different pieces. 2 weeks ago, we focused on the impact that roads have on the environment. And today, we're going to focus on the role that planning and locating the road plays in reducing those impacts. 2 quick pieces of housekeeping. We are going to save time at the end of our presentation for Q&A and discussion. You are welcome to type your questions, though, at any time throughout the presentation. You can do so using that little question part of your Q&A panel, or if your GoToWebinar panel, I should say. Our webinar is going to follow a very similar format to episode 1. We're going to have a presentation that's a little bit more on the theoretical side. And then we're going to translate those principles into actionable steps that you can take using a geometric design software. So that'll be the second half. Now we're going to be again showing you in Softree's geometric design software called RoadEng, but a lot of the steps apply regardless of which platform you are in. Our presenters, just giving them a quick little bit of an introduction. So first off, we have Jeremy Araki. He is one of the principals and founding members of On-Site Engineering. He has over 2 decades of experience working in Western Canada, and his experience spans initial planning, detailed design, construction tendering, inspections, assessment of older roads, and so much more. Jeremy has helped to develop the engineers and geoscientists of British Columbia's professional practice guidelines for crossings and professional development, and he has presented numerous courses on crossings and roads for associations, industry, and government clients alike. Next, from the Softree side, tackling that how to apply it in the software, is Matthew Dickey. He is also a PEng and currently holds the title of Applications Engineer for Softree. Matt's previous work experience focused on the development of access infrastructure in both the forestry and the mining sectors, and has allowed him to add tremendous value to working with Softree's clients, as well as shaping the development of the RoadEng software. And then finally, I would like to introduce, in more of a contributor role, Brian Chow. Brian Chow is a professional engineer who has worked for the Ministry of Forests for over 35 years. Currently, Brian is responsible for engineering standards and policies associated with forest roads and bridges that are referenced broadly, as well as external to the ministry. Brian has a particular interest in promoting knowledge and professional involvement of resource road engineering practices for forestry professionals, engineers, and other practitioners, and has supported the development of this training series with his advice. He's also collaborated and supported with the Engineers and Geoscientists of BC and the Association of BC Forest Professionals in their development of joint professional practice guidelines in the forest sector for crossings and roads. So I just wanted to say a huge welcome to our 2 presenters, and Brian is a contributor. Thank you again for the role that you play in our webinar. And with that, enough from me. Let's get into the actual content. I am going to pass it over now to Jeremy Araki. Welcome, Jeremy.
Morning, everybody. Again, thanks for staying up late or getting up early or tuning in. I hope to be a little bit more clear today than I was a couple weeks ago. I was on day 5 of COVID, if you remember, so I crashed and burned pretty hard after the last presentation for the next couple of days after that. But all's well and good today. So today, as Erin said, we're gonna focus on on the initial planning and locating the road. And again, like we talked about in the next 2 webinars after that, we'll kind of dig down into a couple more of the, or a few more of the details, although I'll be kind of speaking today. But we're starting here because it's really the most important part. As the quote from Brian Chow, the most important time in the life of the road is the moment you decide where it's going to go. And that's true because it impacts everything. So today we're going to move, and through the series, kind of move through the 30,000 foot level and dig down as we go. And I'll do a bit of that zoom in, zoom out today. But since this is about planning and design and locating, I'm going to be speaking about it fairly broadly. And again, as we talked about in the first webinar, what planning does is it gives you time for all the following phases and to figure out all of the factors that are going to impact your road, the environment, and impact the design and the parameters, or the design parameters you use in the road. For example, if one of your goals is to minimize sediment delivery into water courses, and if you can remove the water courses altogether, if you can just avoid them, that reduces a ton of your risk, more so than in digging down and trying to design the perfect crossing. If you don't have to cross at all, you're better. One of our main clients here on the island says the best crossing that we design for them is the one that we don't do at all. It saves them money. So another one of remember, we're speaking more specifically to impacts in the environment. We're going to touch on things that don't seem directly related, but that's not by mistake. And I think as we talk and think through these things, you will recognize how each one of these can impact it, because we're not always going to have the same values. If we're talking about safety or economics, that's not always going to line up with minimizing impact on the environment. So, but those decisions are going to impact where your road goes, and in the end, their influence on the environment. So today's tools, and we talked about it a bit before, they can be pretty sophisticated. Not that old tools weren't. I've got a picture up here of a drill rig that we ran into up in the Yukon, and our drill rigs look significantly different than that now, but back in the day, they're still doing exploration and trying to figure out what's in the ground. Oddly or funnily, we still don't do a lot of subsurface investigation for our resource roads, like geotechnical drilling. But what we're going to be doing today is kind of stepping through the process from project management, touch quickly on authorizations and compliance, how we're using the road, where it is, what the geology is like, and then how sediment, again, in the same theme of water throughout, and then how the climate weighs in, and then those other effects of wildlife. But also today we're going to talk about maintenance, deactivation, and decommissioning, because those do tie back to the planning, or can tie back to the planning and locating stages. So I guess, first of all, starting back at the beginning, we showed this graphic on the first one. We'll talk about it a bit more, but like we said, any project is made more successful when it's managed properly, and that planning process is made possible through coordination, or appropriate coordination. Here in British Columbia, we use a professional reliance model with one coordinating professional who takes responsibility for the whole road. We have guidelines around that. And it helps create continuity throughout the phases and help ensure that all phases are considered at the planning stage, and then the plans are actually carried out during construction, use, and deactivation. But registered professional or not, having someone that responsible person, it helps in the process regardless of who it is. And in my practice, what I've found is we can't help it as practitioners, whether associated with the professional association or not. When we're responsible for something and we see it all the way through, we take that on personally. And when folks do that, we tend to get better results. So in this life cycle process, I think what we're highlighting this time is that in the planning and design stages, although it's a process that goes from one to the next, in the planning and design stages, you have to consider all phases: construction, use, maintenance, and deactivation. And for example, if you have a temporary road, you may build that, or you will build that road differently than if it was permanent. And you may have things like temporary fill retainment structures, so you don't have to either reach down the hillside and get that fill later, or you don't have to end haul material away. This example is obviously not the greatest. It was a temporary fill slope retaining structure that was made more, well, it tried to be permanent, but it didn't make it. But good planning will help you make more realistic expectations, because you know what's coming ahead of you, and you can make good decisions on. And for example, this structure may not have been wood, or it might have been cedar for a longer structure, or it might have been steel and concrete. But if you're planning ahead to all the phases, you'll see that. Now, just quickly, and this is not a talk about authorizations and compliance, but I think it's important to talk about here, because every jurisdiction that you are working in around the world is going to have some sort of operating rules on the land base, and obviously knowing what those requirements are is important, and they're going to be different in different areas, but there's some things that are going to probably be common, like riparian values around streams, arc features, fish, obviously, or even sensitive or rare ecosystems. In Canada here, that can be the Department of Fisheries or Oceans, or provincially it can be Ministry of Environment or Ministry of Forests, and include things that are, aside things like old growth management areas, as an example here. But you have to think about those areas of authorization and the constraints, and they may change based on what you're actually doing. So here in BC or in Western Canada, there's different, depending on what you're doing on the land base, you maybe have the same activity of, say, road building, but depending on what that road is to, it could be different. So if it's a road that's going to a mine, it'll have an environmental assessment, and it'll probably be associated with a special use permit instead of a cutting permit. And it'll have different rules around how you can do that. In the bottom left of the screen, there's a picture of a placer, of an outfall on a placer mine. Now, for example, in the Yukon, if you're a placer miner, the rules are totally different than if you're a hard rock miner. One is a few pages long, and the other is, full EA, full environmental rules. So even within the jurisdiction, depending on what you're doing, can change what the rules are. So how do we figure out how we're going to build the road or what we're going to do? Well, we need to make sure that road is safe. Well, what does that mean? What does a safe road mean? Well, we need to know what it's safe for. And so that starts with the road users. And that's not only, understanding whether it's industrial or recreational, community, but it's the mix of those. And you need to consider the traffic volume and the volume of each type of those vehicles. For example, a road that you can control all access, you can make it radio controlled. That is, every vehicle has a radio, and every vehicle knows where another one of the other vehicles are because you're calling, versus what we mostly see is radio assist, where kilometer markers are there. People with radios are calling, but there's always going to be folks without radios who are using the road. So understanding those even at the design stage is important, because it may or it will change some of the parameters that you use. And those design parameters, those are things like, design speed, seasonality of use, duration of use, the actual size of the vehicles, and the volume of those. And of course, stepping down that to the next, that impacts your road geometry. And like I said, we'll talk about in detail about this in the next seminar, but that's, road width, surfacing type, horizontal and vertical curves, sight lines, so right away width, and the overall cross-section shape, from the crown to super elevation on higher design speeds, the size of your ditches, what your surfacing is for the speed, or your cut and fills for how long it's going to be there. So when you do a lot of road planning in an area, like in your area of your geographic area of practice, some of this stuff, and why we're mentioning it here, can fall into the background, because it seems like it's always the same. But I think it's important to go through the process every time, just to ensure there's no new parameters or slight changes. And we'll talk about this a bit later, but for example, changes in climate, or changes in some of the regulations that I mentioned before, or if you're stepping from one watershed to the next, maybe it's a community watershed, or maybe you're getting closer to a lake or some feature where the recreation use changes and it's way higher. Well, that's going to change how and maybe where you put the road, because you're going to expect those users. So, that's kind of on the ground. If we step back again to the, kind of say maybe the 15,000 foot level, not the 30,000 foot level, and we start thinking about these landscape level considerations, there's a few aspects that are going to influence the environment at that level, and we're going to address them early here, and because they can kind of broadly influence where you decide to put your road. And that's things like existing land use and development, and mixed land use. In the top picture here, that's a picture close to Campbell River, and you see the line that goes across kind of diagonally from the top to the bottom right. That's actually a park boundary. So clearly there's forestry development, but it's buttoned right up against a park. So things from just understanding where that boundary are, to things like visuals and how and consequence values of impacting things downslope. The bottom picture is it's actually it's a Google Earth. Both of these are Google Earth snips. Well, that bottom one, that's actually just one photo. So on the right hand side, there's a highway, there's residential and some farming, agriculture use, and then there's forestry on the left hand side. And that line, that hard line that looks like two different photos, is actually just a property line at the back of the residential and agriculture area. So obviously, where you put the road, how your operations go, are going to be impacted by that immediate adjacent use. In the same way, that terrain stability is going to play a huge role, and we could do a whole series on just the different types of impacts that you can have, but you need to understand where you put the road and the development that you're accessing, how that's going to impact terrain stability. And sometimes it's not super obvious. This is an example of an area with flat over steep, and what was done on the flat area, a bit of concentration of flows. I don't know exactly what happened to cause these two landslides, but the common one is a bit of concentration of flows from the flat area, or just a change in the moisture regime impacted the slope below. And obviously in this one, there's downslope consequences to having that the landslide is obviously a creek down there. But I guess in general, you need to have the right folks engaged to properly identify those hazards and understand, like what we talked about the last time, that risk equation, so you can properly account for all of the hazards and all of the elements at risk downslope. You know, in the same way, stepping back even more to the watershed level, it's not just the specific impacts on a stream downslope of your road. What are the watershed values as a whole downslope, or that your road is in? You know, in one extreme, you know, will I concentrate flows, destabilize the stream banks, or cause a landslide into a fish stream or a community watershed? But what if you don't cause a landslide, but you do have a muddy road that's you know, introducing sediment in that same stream because of grading? And so the question that you have to ask at this level is, where do I place my road to have the least impact? So in this picture, you know, you got to get down this valley. So you're not going to avoid being in the watershed of that stream for a significant amount of time. So what can you do to have the least impact? Because that stream is always going to be downslope. Well, obviously distance. So how far away can I get from that creek so I have lots of ground in between me and the creek? Or just the overall road geometry, and I guess, like, you're thinking about the road grades. Am I going to concentrate flow if I've got long grades in there? Or can I put the road in a place where my footprint is less, so I'm on more gentle ground, so my cuts or fills are less? And of course, that overall drainage regime, and remembering that the same core 3 impacts we talked about in the last talk, and you'll hear several times here, that water interception, concentration, and redirection. Sorry. So it's not just specific to the stream downslope, but what's in your road corridor. So you might be right in the stream. So, you know, in the top photo there, you have a large plain that you need to cross. Well, how do you do it with the least impact? You're always going to be balancing the amount of fill that you introduce to build your road up to get out of the water, versus not adding that fill and introducing more, you know, foreign potential sediment into that land base or into that wetland. In the lower example, you know, there's a high value fish stream at the bottom or the toe of that slope. And you have to understand the hazard and the consequences that I just talked about. And in the last webinar and in the last slide, you know, what is your element at risk? Well, it's fish and fish habitat. What's the hazard? Well, it could be sediment delivery from the road, construction or use, or landslide. And then what's the consequence? How far, you know, of the expected landslide, how far is it going to run out? Is it far enough to hit the stream? If it's not, how much room do we have between where the landslide is or where the road is and where we think the sediment is going to get settled out by? You know, in normal use road sediment or sediment from an event, do I have enough forested land or undisturbed land to filter that? And the same thing, having the right team in place to complete those studies at the start will help ensure that you're considering all those. And that's done at the planning stage, so you have time to consider those things. And sometimes that means bringing in specialists at the very beginning when you're deciding just overall road location and not just assessing what impacts your road, the road that you've chosen is going to have. Sometimes it's right to bring those folks in early on so they can help decide, to help quantify some of those risks so you can move the road accordingly. And then similarly to that, what's going on upstream or upslope and downslope? Because that can change the hazards from upslopes events as well as when you think about changes to the use that you have upslope or downslope, and then what the consequences of that of impacting that infrastructure are now and in the future, depending on your life of your road. This is a Google Earth image again, and it has a highway in the bottom, but it also has every main utility corridor that you can think of, rail, gas, electricity, everything is sewer is down there. And then there's development below. There's future, or there's past development. You can see there's some landslides up above it. It's also a very unstable area, but you have past development and current development in mid slope there. So all those things are changing constantly. And so understanding that at the planning level can help you do the right thing now for now and the future. So coming back down to ground level from this, wherever we are, 15,000 feet, we need to think about the local geology, because it's going to have a big impact on the cost of your roads, the operability, and how your road interacts with the environment. And it's important to have a broad understanding of the geological processes so you can help anticipate that local geology and then anticipate the impact of that. And this doesn't have to be just through training. We're talking about experience, and especially that local experience in an area of knowing, oh, that looks like that, well, this is what we're going to hit. And we'll dig into some details there for some examples to try to get this down to the reality level where it's useful. But as I said at the start there, resource planning, it doesn't usually include any detailed subsurface investigation. It's just generally cost prohibitive, or it's really difficult to do. You end up doing as much, having as much impact getting the investigation done as you will from your development. So that estimation of those subsurface conditions and broadly how it's going to behave or likely behave, and the slope is going to behave, is critical to not only the details how you'll build the road like meter by meter, but how it's going to interact or influence the overall slope. So the two broad considerations are how the geology influences the overall road location, and then how it impacts the detailed road geometry. And both of these, as always, are impacted heavily or mostly by water. And at the landscape level, this is, the water management in terms of the interception, redirection, concentration. You get sensitive areas, streams, or saturation or drought in areas. But at the local level, it's cut and fill angles, road benching, end haul of materials, like moving the materials along the road when you have excess cut materials, and then how you're going to spoil those. So this broad understanding extends not just into construction, but through to maintenance deactivation, because some of those activities are going to be driven by how sensitive the landscape is. But again, especially how it's impacted by water. And not to be repetitive, but that interception, concentration, and redirection. Remember, we're always going to have an impact, but what is that impact going to be? Well, a couple of examples. Understanding of what you're dealing with and how it will react is critical. On the left, we have a deep superficial material. This is a till, and it can be pretty heavily influenced by water, and it's not stable at the angle that it's cut right now. It's obviously going to ravel over time. So how is it going to ravel over time? What is the impact of filling that ditch up, knowing that cut slope is going to ravel? And then how are you going to deal with the end haul here? Because clearly we have an excess in cut, and knowing beforehand what that means. So if you contrast that with the picture on the right, that's a bedrock road in steep ground again, but full bedrock. So we don't really have any sediment issues, but we still are going to have end haul. So we have to get rid of some of that material. Well, planning for the sites where those are going to go, or how you're going to stack that, totally different. you know, you have lots of flexibility with the photo on the right with shot rock. It's well drained, it's stacked steeply. You can put it closer to, you know, water bodies or streams. You can put it in areas where there's more water, whereas, you know, that till that's on the left, that's a silt till. So that's not going to stack at the same angle. It's not going to be, it's not going to have the same internal stability, and it's certainly far more sensitive to water. So how you deal with those two different materials is totally different. And so understanding that ahead of time before you dig into the slope, you know, understanding what's going to be under it, that might change where your spoil sites are, how many spoil sites you need, and then how much management those spoil sites need. I not a big, a significant part of my practice is going to these roads where there's problems, and a lot of times it's just dealing with the spoil sites. And you know, for example, for a few of our clients, we have to do detailed design with spoil sites with slope modeling to make sure that that spoil site is stable. So if you don't understand your land base and the geology, you might not know what you're going to hit as you go ahead. In the same way, another example, and this one, again, I apologize, some of these are fairly BC specific, but this is colluvium. So, you know, a colluvial slope on the left-hand side, you can see just a regular planar slope. You should be able to build a road across there with some, you know, maybe not conventional cut and fill, but with a bit of end haul. But if you can see in the middle of that picture on the left, there's a white rock. Well, that rock in the middle picture, there was some blowdown there that exposed that. So what was underneath there was this really blocky gap or poorly graded colluvium. Now, at the angle that was sitting, because colluvium, remember, it falls to what it's stable at, and it might be, you know, factor of safety of 1 or 1.01. In that particular type of colluvium, I know what happens there. And we actually moved this road, and the picture on the right is not the same area, but it's the same type of ground. And that is a retrogressing cut slope in colluvium. So that I'm standing on the road, the current top of that retrogressing cut, the headscarp, is over 60 meters above the road now. And in places, it's still over 2 meters high vertically or overhung a bit in that blocky colluvium. So you can see some of it stabilized, but that's going to continue to retrogress until either the colluvium runs out or you hit the top of the hill. So understanding the landscape and where you can expect those kind of soils, you know, looking for the rock bluff above, or knowing the history, going back to on the first slide there, we had a picture of geology, you know, overview geology mapping. Understanding those things is super important. But then as you move downstream in the watershed, there's other impacts. As the water courses get larger, there'll be larger events and the broader impacts to the surrounding terrain or from it. And although you may not be able to avoid the things, at least you can quantify them. On the right-hand side is a fan, and this one has residential development, but there's development on alluvial fan. And we have lots of these developments from times where the processes either weren't fully understood or investigated or even thought about. And obviously now we recognize fans and the behavior of those and cones, and we can plan for them. So, you know, for example, on a fan now, we know how important the forest or vegetative cover is on the fan. So we maybe won't even log there if it's for forestry, or we'll narrow a right of way and maybe even leave high stumps in a right of way or woody debris, because we understand how much that impacts water movement and avulsions on the fan, and actually helps us investigate it and understand kind of the frequency of events on a fan. So like I said, you can narrow the right of way up, or make your road really low profile, no big cuts and fills, and undulate the grades. So, you know, if we're expecting a fan to avulse during the lifespan of our road, we don't want to divert the flows We wanted to let it do what it's going to do, what it was going to do when the road wasn't there. And so we reversed the grades. And so if it does avulse, it should just still flow across. Or we can do things like adding crossings at expected areas. Once we do the fan investigation, we can start weighing where we think that water is going to go, and then deal with it, anticipate it, and deal with it at the road in case those events happen. You know, backing up again, I guess, to more of the, not landscape level, but investigation level, we now have a lot of tools that we never did before, like publicly available digital elevation models, or DEMs, and super cost-effective LiDAR. So we can start to identify these processes even before we're on site. And Matt will talk about this a bit more, but you know, in the DEM on the right hand or left hand side there, it's pretty obvious that there's some stability issues, and that's kind of an extreme example. But you can start to pick these things out, and even features like the shallow instability on the right hand side. That's just a highway fill slope, but you know, we still, even on the flatter ground in fine grained soils, with good digital elevation model or good LiDAR, you'll be able to see these things and do it before you even hit the ground. So you can start deciding where to, or try to avoid these things as you go. And in the same way, you can be analyzed at the landscape level, but more, you know, kind of more of the subtle features. So in this DEM, you can see that there's kind of some gullies, some terrace slopes, and we know that those steeper slopes, they're at their angle of repose. They're standing at what they're able to at a factor of safety of unity or a little bit above. And if you touch them, you know that they're not going to be stable in the long term. But you know, a lot of times we need to climb up through these so we can start to help identify some areas of instability. As you can see on this one, I hope at the top, or kind of mid top left hand side, you can see the outline of an old head wall of instability on the, I guess would be the right bank of that gully. And so you might not be able to see that very clearly on the ground, but now we can identify those features up front. Or you can see down to like the little scallops on the gully that's coming down on the right hand side. That's super clear in the LiDAR, but you might not see it on the ground. This is a great piece because it's got a lot of things going on, and you see there's a fan in the bottom left hand spot there as well. So again, if it's an older fan, you might, the vegetation cover might not be much different. And before you even get there, you can see that. So you can be looking for those little pieces of evidence on the ground of, buried stumps, rocks or gravel that's exposed and not covered with the same amount of forest floor cover that the other areas are. So that's a super, super useful tool. And in the same way, more specific to material, you want to understand how it will behave when it's disturbed, or maybe how useful it is. So knowing that up front, you can make a plan in this. And again, these photos are just for example to talk through. Sometimes it's not possible to do what I'm talking about here, but on the left-hand side, you see there's a road on the, I guess it would be the river right on the flat, and that's a flat, swampy, silty. You can see there's a lot of puddles on the road, piece of ground to put that road through. But on the right-hand side of that is a gigantic sand and gravel terrace with oodles and oodles of good granular road material that you could use in your road construction. So seeing those features up front and understanding the geology could maybe help you, cross that stream earlier and move to the other side where you could have access to all of that gravel. On the right-hand side picture, I added more for interest, but it's a picture of a road, and then the adjacent development to that road is in a shallow ice-rich permafrost. And when you disturb that shallow ice-rich permafrost, it's going to degrade, and you're right adjacent to the road, and that's going to have an impact on the road and the stream. So even, understanding that local geology for your adjacent developments is going to impact the road. So from that local geology, we zoom back in to sediment, and again, like through the whole series here, we're talking about water, minimizing, not getting rid of interception, accumulation, and redirection. We know they're going to happen. How do we deal with it? We can't avoid it, so we have to account for them. At the planning and locating side, understanding the superficial materials, so that's reviewing the geology and knowing what's coming, and finding the specific features that may be less erodible, because we know that forest roads or resource roads and crossings, whether it's bridges or culverts, they're sources of sediment. They are, and we need to locate, design, construct, inspect, and then deactivate these roads, recognizing that they're those sources of sediment, and they can have impacts, negative impacts on other resources, and not just the water quality, but fish and fish streams and fish habitat, all the things that we discussed in the first webinar. And consideration for management of that sediment should be made not just through construction, but through the life cycle. And it should be for roads and crossings, and it should be thought of at the planning stage, because I said this in the first one, it's almost always, or you could say always, more effective or efficient to integrate this kind of management early on, rather than dealing with it in a reactive manner when either your structure's already damaged or you've impacted something adversely. And what do we do? What do we manage for? Well, we're trying to minimize development and then the movement. And in the next webinar, we'll maybe get into a bit more of the details of the how-to. But in general, knowing your materials and minimizing your footprint, that's what's important. These photos that I put in here are a little bit tongue-in-cheek. These are placer operations. But even in a placer operation, when your main goal is to make sediment, you have to think about how you're going to manage that. And the photo on the left-hand side is it's actually a dredge, like a historic dredge in Yukon, and they're making mud there. But you can see in that photo that they've separated their operation from the river that's flowing beside. On the right-hand side, that kind of is what it is for the type of operation that placer mining is. That's pre-stripping to melt the permafrost, and it's right down to the creek. But instead, know your jurisdiction and the rules around it. And more specifically to roads, and as we spoke about before, you need to have the appropriate drainage structures. And think about that even when you're upslope. Like on the photo on the left there, where you have very limited sediment potential. It's a bedrock road, gentle ground, up the slope, probably away from fish values. But even with that, we have to think about that interception and accumulation. We know what's going to happen. So that picture is a guy, doing some planning with all the culverts that he's going to have, that he's going to install there. And on the right-hand side, in this particular picture, this road has to be here, and it's right beside the ocean, and so you have to understand that and then account for it. And it doesn't always get worse over time. In this particular example, we can see that the vegetation has grown up, and it's given us a great filter from the road. And you can't see it very well, but on the cut slope side, the cut slope is fully vegetated and that ditch is vegetated. So as long as the fills that you have going down to that water body are stable, you've actually improved your situation. In this case, this is a main line, so the surfacing is actually still pretty good. So it's not causing that many issues sedimentation. But all of these things, they can impact. Oh my, I'm burning through time here. They can influence things like the time of year that you can build or use the road, or rainfall shutdown guidelines, or maybe temporary sediment confinement structures that you need to use. So again, you can't always avoid water. So how do you minimize the sediment delivery? Clearly not by fording creeks as in the left-hand picture, but even when you're, right beside a water body, how can you minimize sediment delivery through your road grades, like we speak about before, or putting swales in the grade in places where you have more room for that water to filter before it hits the water body, or just choosing a slope or a side of the water body that has less erodible materials, or it's gentler where your cuts and fills aren't going to be big. And you can do things like narrowing the road in areas of sensitivity so you reduce your cut. And then you can even reduce that more by doing things like taking the ditch out and insloping the road, and then dealing with that water through insloping and road grade, and getting it to somewhere where you feel comfortable, where you have more room to get that water across. But by taking out the ditch and narrowing the road, you're greatly reducing the opening, the ground that you've exposed. And so we'll get into this a bit more in part 4, but in general, ditches are going to have your biggest impact, because they're the things that are carrying the water. And in this case, we have a couple of examples here. Both look like fairly long ditch lines, which is not always the best, but at least the one on the left is armored. But when it's not armored and it's a long run, you have far more potential to start developing sediment. And as we know, water flows downhill and it flows into crossings. So what do we have at crossings? Well, we know that they're a big source of sediment, or potential source of sediment, because they're directly over the stream. And the important things to think about are your approach grades. So, we see the one on the right there is a culvert crossing, and it flows right down onto the where the stream is, and you can see the sediment that's developed down there. And so now you got to think about bridge lengths, or what type of crossing. In the resource sector, we're notorious to have our crossings in a swale on the secondary or temporary roads, because we're trying to do it on the cheap, and we're maybe have the streams are in big draws or gullies, and so we're swinging in and out of them, and we can't afford to put a big bridge to bridge that across. So we often have grades down onto our bridges. So what can you do with that? Well, you can have shot rock roads, or granular roads, or crowns and sumps. But you got to recognize those are going to change over the times. If you're operating in the wet, or you're dragging more silty materials from the roads that are not surfaced further away on the approaches, or as in a lot of cases, you've got rutting. You can see that on the left-hand side there. It doesn't matter that you've done all those things, you're still going to have sediment that is coming down to your crossing, especially if you're in an area of predominantly fine-grained soils. And so you got to think about that, especially if you're in a watershed that's sensitive to sediment, or like you've got a water intake or fish right there. So you have to consider alternate solutions, such as, adjusting your grades, maybe grading all the way through a crossing so you can move water past it, or changing from a culvert or a bridge to a culvert, so you can have that. You can have berms across the culvert so you're passing water over, or maybe you need to lengthen the bridge and get it out of the swale, or maybe you just need to reduce your rainfall shutdown guidelines, or when you're using it. But you got to make sure you plan for this. And so now, and we've started this in BC, and you see it more and more. This is an example from GWB, where the erosion and sediment control plan is actually built right into the bridge design. And so that's specifying the things we just talked about, the crowns, the grades, the culverts, and the settling areas, maybe some curtains, but lengthening the bridge doesn't always mean getting it out of the swale. Lengthening the bridge can mean below your riprap or the fill slope that's reposing down from your road, you have more area, like in the dark green on the example here, where that water is able to filter through. So on that, how is all this being impacted? Well, it's impacted by the local climate. And you need to consider the potential vulnerabilities based on that local climate. And that's temperature, precip, and then seasonality. So some of our risks include flood, wildfire, landslides, rock slides, avalanche, extreme precipitation. And you have to consider these through the whole life cycle, right from planning through deactivation. So that's things like construction season. When can I start to build and how long do I have? That's going to impact your planning of start dates or even length of construction for areas with very short seasons. Again, important to understand at the planning stage. And then things like snow. How much snow am I going to have? Am I going to have drifts? Am I going to have big snow banks that have wildlife impacts? And then the impact of the top right picture there, that the cold climate on fills. If you've got a fine grain fill, you're going to get that freeze thaw that's going to impact the stability of your fill slope. And then concentrating drainage, the picture on the bottom left-hand side, that's fill slope erosion from in the springtime, the snowbanks where it's breached in one spot, and now the water's running down the road and finding a hole in the snowbank where it's going to erode the fill. But you have to understand things like peak flow and how what impact that's going to have. On the coast here, it's early fall or winter storms on these short, steep watersheds. In other areas, it's going to be more driven by snow and how that impacts, and that's going to impact how you design and your seasonality of use. And then what do your shoulder seasons look like? Are you going to need to operate through spring breakup? Well, if you are, that's going to impact your ditches, your surfacing, your right-of-way with how you manage the snow, like winging the snow out so you don't have those larger banks during breakup. And so that's a maintenance strategy, and you need to employ that and understand it well before you get it. And not only we have this, we have a changing climate now, and understanding that changing climate is important. So I'm just going to pass it to Brian to chat about that.
Thanks, Jeremy. So Jeremy's just finished discussing some of the aspects of local climate. However, those climatic conditions are changing, and the changing climate must be considered in the full context of the life cycle of a road. The science is really definitive that human activity has had an impact on global climatic conditions, which is resulting in local climate change. For BC, British Columbia, there's a variety of terrain and geography, resulting in a broad range of climates from arid through to coastal. We're observing changes in local climate that are harbingers of more to come. Temperatures have and continue to increase, and correspondingly is impacting climate parameters everywhere. The image on the lower left showing British Columbia shows temperatures in the left frame from 1961 to 1990, the mean annual temperature. The image on the right is the projection to 2080, and so it's pretty dramatic what kind of temperature changes we're likely to encounter. Now, the climate change science is still relatively new and coarse, and to say climate change projection is complicated is an understatement. The science continues to evolve, and projection models continue to be refined, but the projections aren't getting any more comforting. There's still lots to be learned. The engineering branch of Flora has been undertaking investigations of climate change impacts on resource roads for a number of years. Our ongoing efforts can be found on our website, which will be provided in the resources that you can access through the site where all these presentations will be posted. So likely similar to other jurisdictions, we anticipate and we've observed increased frequency and more extreme events. A great example happened in British Columbia in November, where we had a series of successive atmospheric rivers that resulted in storms which severely impacted the public highway and resource road networks across the southern half of the province. For a period of time, there wasn't any major highway access from the coast to the interior of British Columbia. A number of the public highways had been damaged. People had to go through the states in order to get to the interior. So some of that damage to roads and bridges, the bridges had been designed for 200-year return period floods, and they were still damaged. The repairs to that road infrastructure has been underway since the storm subsided, and it's anticipated to take a number of years and a lot of resources to address. So practitioners must consider impacts from climate change in their activities. In British Columbia, it's an expectation of registrants of the professional associations such as Engineers and Geoscientists BC and the Association of BC Forest Professionals. It's a requirement of professional practice. So for roads, what that looks like is evaluating what vulnerability a road has to climate change, and then addressing those vulnerabilities through the life cycle phases of a road. In BC, the vulnerabilities are varied, but there are some that are pretty obvious. Flooding and increased prevalence of landslides arising from increased higher intensity storm events and runoff as a consequence are predominant vulnerabilities. At the other end of the spectrum is drought and wildfire. Impacts from wildfires becoming more apparent besides direct fire damage to road infrastructure. Wildfires remove vegetative cover, which intercepts and helps with retention of precipitation. So as a result of wildfire, we're seeing not only greater runoff due to lack of interception and retention, but we're also seeing consequences associated with the formation of hydrophobic soils as a consequence of the heat of the fires, which further exacerbates the runoff. We're also anticipating with drought periods impacts to road surfacing and retention of fines. One of the significant impacts of that is dust, which poses a major hazard for visibility and such, and as a consequence, safety. In BC, resource sectors have relied on winter and cold weather to freeze in roads to support industrial activities. What we're seeing is increased freeze-thaw cycles such that roads are not freezing in or are melting, leading to severely damaged roads if they're continued to be used. We need to identify what vulnerabilities can be anticipated and then consider and address them in the context of the life cycle of the road. Some of the opportunities, including building infrastructure that's resilient to climate change, mitigative measures such as implementation of dust control, or adaptive measures such as modifying how we conduct our activities, changing the seasonal timing to avoid operating when roads are soft. So at the end of the day, we need to consider climate change, and an objective is to have a reliable climate change resilient road infrastructure. Back to Jeremy.
Thanks, Brian. So moving on to local flora, fish and wildlife again. We touched on this in the first presentation, but local plants and wildlife are what you need to ask yourself. Are there organisms in the area that are endangered or sensitive to disturbance? And then how can you avoid them? Is there something we can do to mitigate our impact? And usually the answer is the same. It's minimize your footprint. But how do you do that? Well, simple avoidance is always best. You just distance yourself from the resource. But then, you know, if you can't, you need to minimize that conflict. So again, all of these things are going to happen through planning and identifying them up front. But, you know, how do you minimize conflict? Well, there's simple things like make sure your crossings are on creeks are perpendicular. What I find is overlooked a lot of times when you're crossing a stream is understanding exactly where the corners of your bridge or the ends of your fill on a culvert are going to be, and then what those stream banks are looking like. So if you're trying to figure out how big a bridge needs to be, even if it's on a temporary road, you have to look at the stream bank, and is there a stump or a tree that if I have to remove that, I'm going to remove a big chunk of the stream bank. Or even understanding that, you know, if you're putting a bridge in, that even if you leave that swath of vegetation between the stream and the cut for your riprap or road fill, that once you cover that with a bridge, it doesn't have sunlight anymore and it's going to die. So how are you anticipating that, and what's going to happen when that vegetation dies and potentially exposes the soil underneath? But again, minimize things. How can you plan your roads to be shorter, which saves money? Or do you need to have compensation, build something around to compensate for what you're touching? But that goes right down to lifespan or your operating windows. And that's down to the planning level of what's your standard operating procedure for sightings and how do you report those sightings, all the way to, you know, having the right evaluation for not putting culverts that are perched in a fish stream or not using a bridge at all. And that's not just the fish and wildlife, but on the flora side, continuing to monitor for invasive species or looking at the impacts on the vegetation that you're having, especially if you're thinking about climate change and dust, and doing that monitoring. So that's knowing your development at the landscape level and those potential cumulative impacts on the development. And how do you do that? Well, you do it through the team, the correct team, so you identify all of those elements at risk. And that's the adequate study of an identification of all the features, right from, you know, birds and nests or leks to fish studies or understanding ungulates, understanding winter ranges and bear dens, and know the regulations, what the buffers are on a goshawk nest or so forth. And you don't, we're not just talking about spending extra money. Sometimes getting that biologist involved up front can help you. You know, we already talked about, you know, reducing right away at crossings and the grades and not having an impact, but sometimes we can have even less of an impact by putting something like an embedded culvert in. So we've been doing a lot of these, as you know, the bridge and steel prices are high and fluctuating greatly, so it's hard to plan. So we've been putting in these embedded rounds or simulated stream bed embedded rounds where we have gravel inside the culvert, so we can still have the natural passing of bed load, but we're able to put in a culvert, and it gives us flexibility of grading across, having the road grades go right across a stream, or having it in a tight corner where a bridge we'd need straight areas on each side. So now we're reducing cuts by being able to turn right over a culvert. So sometimes you'll have less environmental impact and also spend less money. Or, I mean, you know, at the grander level, thinking of you know, the frog fences and frog culverts or wildlife fences like they have on some of the main routes. And I think, again, I said this at the very start, but we're all environmentalists here, and we're the ones that do the work. And I'm not saying that the environmentalists who protest and try to bring light to issues and act crazy, there's nothing wrong with them either, but we're the environmentalists who actually do the work and ensure these things are minimized. So we're doing all this through this planning. So looking ahead at future phases, how do you deal with these impacts? Is there a reasonable way? And that's planning for maintenance. And broadly from the planning side, we're thinking about overall landscape and road geometry and how that has an impact. And that's important to make that plan, and not just plan for the maintenance activities, but for the inspections to make sure that's completed, because we know that these maintenance activities can have a large impact on the environment. And mostly that's about sediment. And we've spoken about the design concepts to minimize that, but it all starts with a plan. And what are the main things? They're water and drainage management, and then that surface management. And so that's, the most common thing is grading. Kind of an extreme example on the left-hand side, but what are the critical elements? Well, they're crown and surface water management. So that ensures, and it's not just about the environment, it ensures that we have faster traffic volumes. Our surfacing is more resilient because we're shedding the water off it, and we're not having potholes, which vehicle damage, sedimentation. I think a lot of people misunderstand predominantly what is behind the creation of potholes on resource roads, and it's not subgrade, it's pumping, and the pumping from water sitting on the road surface, because you're not in a crown, so the water sits there, something drives through it, it pumps the fines out, makes a big hole. The hole gets bigger and bigger, it's self-propagating. And then greater berms, they're the enemy most of the time, other than double ditches, which we'll talk about next time. But don't let grading be that secondary activity. Oh, Joe's got nothing to do today, send him on the grader and scrape the road off. And Joe will literally go and scrape the road off. He'll scrape the surfacing into the ditches, he'll scrape it flat, and maybe fill a ditch. In the other side there, we have what happens when we don't maintain our ditches and culverts. We can concentrate flows onto fill slopes. And what does that have? What impacts does that have on the life cycle? Well, that's the seasonality and the traffic types. Those are the things you need to consider when you're considering the surfacing. Design speed for your road crests and grades, and that all ties back into that initial planning. Another important thing that I don't think we think about enough in the forest sector or in the resource sector is understanding things like the durability of the aggregate. So how strong is the aggregate in your surfacing, and then what will it weather into? Is it going to weather into sands, or is it going to weather into silts? But understanding gradation of surfacing and how that impacts stability. I was up north, and a highway supervisor told me that aggregates are no good for road surfacing, and the example was that look at the road surfaces, they're all silt, and the aggregate's all on the side, so you don't need aggregate for your road surfacing. Well, if you have that, you're going to get what you have in the picture there. The problem with that particular road he was pointing at was not that it had aggregate in it. The gradation wasn't right. So you need the aggregate to create the base of your surfacing, and the fines, that proper gradation will lock that all together. But it's not all about grading. We talked about the impact on wildlife, how you maintain and break girder, for example, break your snowbanks. Perfect example here of ungulates or moose in this case, on the easy path. and struggling through the snowbanks on the side. So what can we do to avoid that? Well, we can have escape routes. But in the same way, I mentioned it quickly earlier, maybe we should be winging those back anyways. So in the springtime, we don't have a corridor of melt. And that goes all the way back down to planning at the initial stages to make sure your right of way is the right width and your fill slopes are the right slope. But you also need to think about things like seasonal deactivation. On the right-hand side there's a cross ditch over a water bar. Now, cross ditches are just what they say. They take ditch water or flows from the ditch side across the road prism, and that can be even just as a fail-safe beside an existing culvert. Or temporary water bars. So water bars are just interruptions to surface drainage on the road surface that direct the water into the ditch, or in a reverse water bar, it directs it over the hillside. And so that'll save your surfacing by not letting long grades develop sediment over time. And so those things you need to think about at the planning level and then during use. So if you're going to be down for a while, you can plan for those things and do them before it becomes an issue. And I can tell you that seasonal deact with road surface erosion is far more expensive to deal with after it's eroded your surface, rather than have an excavator cut in some water bars. And so, finally, what do you do at the end? You decommission or you deactivate. And your ability to maintain and then decommission a road in a timely manner will influence what solution is best. And so that's on your capital expenditures, your operational expenditures, well-being, your safety, environment, and other operational requirements. And then deciding what that acceptable level of performance is and designing around that. And this isn't isolated to the resource sector. Everywhere we have spring closures or no stopping signs. Understanding that behavior of the road is common to all sectors. And in deactivation or decommissioning specifically, we talked about it a bit earlier about, how steep am I going to cut that so I can figure out whether I want to end haul material or not. If I'm a temporary road, I might cut steeper or temporarily store my fills, so when I deactivate, it's easier. So, for example, on the picture on the right, we don't want to have, if it's a temporary road, we don't want to have long fill slopes and be required to have a specialized excavator to retrieve those when we go to deactivate. Or maybe on our crossings, we'll have modified fords. That is a swale with pipes that carry low flows, where we can just remove those pipes and the surfacing and just leave a rock swale in as we deactivate that road. So knowing that lifespan, you can design those things up front. And again, that planning process gives you the ability and the time to do it thoughtfully right from the start. So very sorry I went over time. Now Matt's going to tell you how we can actually do these things. Matt, you're muted.
Thank you. I'm talking to myself. So yeah, I'll apologize in advance. I'm going to go over our allocated time. If you can't stick around for the whole thing, we will put the recording online afterwards. So with that being said, let me just... So I'll continue picking up where Jeremy and Brian left off. A lot of the stuff they covered, there's not going to be a specific tool in the software for it. Some of it is just a matter of recognizing that we have to account for things and making the plan accordingly. So I am going to focus on the stuff that we can address in the software. Before I start right into the software, I'm going to just narrow in a little bit on the term planning and locating for what we're using here. So that can obviously cover a pretty wide swath for how close we want to get the road. In this case, I'm going to speak to it at a fairly high level. So we want to make sure our road's in the right general vicinity at this planning stage. And we want to know that it'll work, but we're going to work on refining that with the tools we'll introduce in the subsequent webinar episodes. Now, the line that separates planning and design, you need to recognize right off the bat that that is an imaginary line. There's nothing saying planning stops here and design starts there. For our purposes, and we are, and we're doing that mainly for time. So we can't cover all the webinar stuff or all the topics related to this in one go, so we have to break it down sequentially. So yeah, let's talk about those tools that let us get things in the right general area. Big part of that is making sure you know what the topography is in your area. Now, collecting conventional survey data is labor intensive and expensive. So it would be very unusual to do a detailed survey without having some idea of where you'd like to put the road first. So prior to the availability of remote sense topographic data, this phase of the planning process took an enormous amount of time, at least an enormous amount of time in comparison to what it can take now. So without remote sense data, the desktop portion of the planning process was often very coarse, and it often lacked the resolution able to produce a preliminary alignment that had much value. So that is that when you took that preliminary alignment out to the field, it's not much better than starting from scratch a lot of the time. It's still a question of where should I put the road? Where should I collect survey data so I can further refine where I should put the road even. So it had its issues. Now, that preliminary workflow can be and has been improved upon, and to one that's become much more efficient. And one of the big contributors to that is the availability and the advances of remote sensed topographic data. So when we talk about remote sense topographic data from a road design standpoint, the big buzzword that comes to mind is LiDAR. So LiDAR is the preference of many planners and designers, and that's for good reason. So it's suitable for bulk acquisitions. It's often publicly available. It can be very accurate, so accurate to a point where you can rely on it for your construction level designs. And even if it's not publicly available, it's often more economic, well, almost always if you're doing a large survey, more economical to collect LiDAR data than to collect conventional survey data. So by incorporating LiDAR or similar data in your planning process, you can greatly reduce your planning time and improve the quality of your plan. Now, if LiDAR data is not a viable solution for you, there are other data types such as photogrammetry derived data or satellite DEM data. And that's still an improvement over an arbitrary line on a map and the sheer will to iron out where to put the road by wandering around in the woods. Now, that other data, there's everywhere in the world has the best of my knowledge, maybe there's an exception with parts of Antarctica, but anywhere in the world there is DEM data available. So at the most coarse level, there's the SRTM DEM, and I forget what that acronym actually stands for, but it's global coverage or near global coverage. The Arctic has a different coverage, but it's 1 arcsecond data, so about a 30-meter grid. It's free. So that's showing up on the image to our right now. Now, there's many locations where there's higher resolution data publicly available. And that, if you're lucky, that's LiDAR data. And then there's middle ground in between that as well. So the middle image that I have is a 1/3 arcsecond DEM. And then there's other solutions. If you don't have a budget for LiDAR data, you want better better planning data than that 1 arcsecond DEM. An example of that would be AW3D has global coverage of high-res satellite DEM data. So it's not free, but it's an economical solution to give you high-res topo data for large and medium-sized areas. And just before I switch slides here, if we look at these images, it's pretty obvious what we have going on. They're the same areas, and we can see with the LiDAR data, you can pick out a very fine level of detail. You can see channels over here at that outflow of the lake. You can pick up rock bluffs and see the subtle undulations in the ground. Whereas if we go to that 1/3 arcsecond, it's still better than looking at some course map and counting contours, and then same with the 1 arcsecond. So from a planning perspective, obviously, if I were doing this, I'd say LiDAR is my preference. But even if I'm just trying to figure out where stuff's going to go before I decide to purchase and acquire either conventional or LiDAR survey data, I could do my plan with these other data types to at least get a rough idea of what my options are. Now, the other part of the improving our planning workflow equation is software. So without tools to make effective use of that topo data, we're no further ahead. So 2 slides ago, I mentioned how the boundary between planning and design is fuzzy at best. Part of that is because a lot of the time, those design level details can have a significant impact on where to put the road, and accounting for them early makes it much easier to get accurate costs and metrics to evaluate your project in the planning stage. It also reduces costly iterations. If you had a plan that wasn't going to work, you go to do that field investigation, find out it doesn't work, and then you're back to the planning stage and finding another solution. So a common approach to get around those limitations, and it's certainly useful, is to approach road planning with looking at the problem through the same lens as a designer. So I'm not saying that you want to iron out every single detail of some alignment that you haven't even set foot on the ground, but looking at it from a holistic approach and saying, well, I want to put the road here, I think it'll work, but this variable that usually I wouldn't take into consideration until later in my design process is actually going to have a big impact on where we put that road. And the example that I have shown here is cut slopes is a great example for that. And when Jeremy was discussing colluvium slopes, it's one of those things that if you can recognize it early in the planning phase, you can say, well, either I want to take a closer look at that, or maybe I can recognize that that landform exists. I'll change my cut slope angle to be appropriate, even at the planning stage. So I know that, okay, that's too big of a pill to swallow. I want to put my road somewhere else, or I want to at least have an alternative route to save having to rely on that if it's not what I want it to be. And again, you don't have to iron out the whole thing, but just identify those problem areas and save yourself a bunch of headaches down the road. Now, if you're doing that planning in a design platform, it's easy. So you already have all the tools needed to take what you're looking at that extra step further. But if you don't need those extra tools, it's just as simple as not using them. And then the other benefit of doing it in a design platform is when it comes time to transition from planning to design is you've already got the document on the go. And it could be something where you're slowly picking away at it rather than just an abrupt switch from phase to phase. So what functions are in the software to help get the road in the right general vicinity? Well, the main ones are the ability to import and generate and visualize spatial data. So here I've just got a pretty bare bones example. I've got a road showing up in my plan view with contours, and I've got my 3D view. So that's has its own benefits. We can look at the 3D view and try and interpolate what to expect there. Now we can also generate and bring in a bunch of spatial data, and we can generate some of that right in our software, but a lot of the time you're working with the information from a GIS system. So we can import that and visualize it and know where things are at that we're dealing with it. And then the next aspect of planning our road is the ability to take into account our design parameters. So all those details that we'll go into expand upon in our next or our following episodes, but also just if I'm looking at it from a drawing a line on a map standpoint, seeing how that line interacts with the surrounding terrain, so my cuts and fills, and then making sure I can account for curves properly. And if I want a fast road, I've got nice gentle curves that equate to a certain design speed, or if I'm going with a slow goat path, we can tighten those up and reduce our footprint. And then to figure out what the best solution is, we can look at it quantifiably and give metrics to help us make the best decision. So I'm going to jump into a pre-recorded bit in our software. And just before I hit play here, I'm going to use background files. So if you don't have a RoadEng background, the background files are going to be used somewhat as layers. So it's going to be a terrain file that I use as a background. I'm going to create that in their own instance of terrain, but we can visualize those and toggle them on and off and switch their draw order, etc. So with that, let's look at this example that I have set up here. So it's the same example that I previously showed the screenshots from. Pretty bare bones. We're in the location module. And the big tool that I'd use at this phase is just the 3D view. I'm a big fan of it. You can zoom around, you can see what's what. And in this case, I have a geological knowledge, or I know the geological history of the area. It's been glaciated. It's fairly benign terrain, and we've got this long kind of sliver ridge here. So my guess would be that's probably an esker. It looks like that fluvial deposit shape. So as Jeremy said, we'll consider that. And usually eskers are granular material, which is also usually cheap to build with, and also has less erosion and sediment concerns than if it was a fine grained material. So that's a bonus. But if I'm not comfortable with that, or if I just want to make sure and check other data, well, we can bring in shape files. So it'll depend, quality and availability will depend on your jurisdiction for what's available, or maybe it was collected specifically for your project, but I've got surficial geology shape files here. And I brought those in and they just appear as our default symbology. And if I look up in the properties panel, the name of each one of those features is representative of the shapefile name. Now in this case, it's one of those things where it's the actual attribute that I want to visualize. And we're not out of luck. We can just open up the feature panel. We can configure that to show whatever we'd like for attributes. So in this case, I'll just remove all this stuff I don't care about here, and I'm gonna add in the attributes I care about from that shapefile attribute table. So next I'll select everything. I'll click that little eyeball and I can see what I'm working with. So I've got each feature type delineated. I've got eskers, game fields, bogs, ground moraines, and terrace. So I'll just select the esker to start. I'll go over to my properties panel and I'm going to change the hatching for that so I can see what's going on and make it obvious it's something different from elsewhere. And of course, we can go through, we can do that for each item. We could sort these and group them together. In this case, I'm just going to do a multi-select and grab all my other gravel and sand deposits, and I'll color them differently. And again, it's that idea that if I know beforehand where things are at, well, let's just highlight that. So if it's a choice between putting the road somewhere that is a fine grain material or a nice coarse grain material, we can choose appropriately. So I'm going to take that terrain file that I've just saved, I'll add it in as a background, and then we'll see where we're at. And there, it confirms what I thought. And so that's good, but it confirms what I already suspected, so I'm just gonna turn that off. Now, in this example, we've got a little bit more going on. So if that's all the information we had, I would assume I'd just come off the road from my existing point and follow the esker. Now we've got a rare bird nest that we have to contend with. So for that, I'll bring that in as a background as well. In this case, I've only been given that point, or the nest as a point. And it's one of those things that'll depend on specifics, but just not knocking down that tree is probably not an appropriate management strategy. We probably want to give it a wide berth. So we'll first make sure we can see that, and then we can buffer that feature out and get a no work polygon. So I'll just right click, modify, buffer, and away we go. And there's all sorts of tools in the software to modify the line work that you're working with. All right. So once again, we'll bring that in here, dump it in as a background. And the next item that I have is, so now we're not just coming across the ridge. So we're actually gonna have to deal with some drainage stuff. So I'm gonna use a tool that we've added in version 9. So version 10's to come out, so it's been in there for a little bit. But I wanna create polygons around my watersheds. So to do that, I'll again jump back into terrain. And I'm going to use the tool. This tool, most of our software is uses tins. So this is one of the exceptions to that. So we're going to use a grid for our surface. So I'm going to make it a 1 meter grid. I'm going to add a depression fill depth in there just to smooth out any little low points that I want to allow water to run through. And I'm going to reference my topo surface to generate this. So it'll run through. It takes a little bit to calculate. And there we are. And I'm just going to change the symbology here. So rather than transparent polygons, I'm going to just change it to suit my personal preferences and make the line type around them a little more obvious so it shows up on your guys' screen instead of just mine. And once again, I'll save that and dump it in as a background. Now the next tool that I'm going to show is similar in function. So it's based off of a grid calculation and it's related to hydrology. But that's our streams tool. So the streams tool is a version 10 feature. So we're getting close to releasing that. So it's a sneak peek, but not that much of a sneak peek because things are getting close. Go back into terrain. I'm gonna find that tool in the same location. So it'll be under the terrain modeling tab. And in addition to just creating vectors for the actual streams, and the streams will be generated if we have a drainage area greater than a 1/4 of an acre. I can change that value as I see fit. But it's also going to generate polygons at depressions. So streams are obvious and why we want to know where those are. Depressions are relatively obvious as well, but it'll delineate things like wetlands and ponds and vernal pools. And all these things usually have high ecological values. So it's not an easy button to show you exactly where to put the road, but it certainly helps you decide where not to put the road, or at least anticipate those interference areas if you have to figure out some other solution. And just dumping that back in there. And there we are. Now, the next thing I'm going to show is kind of a deviation on something that we often show in our webinars, and that's just the fact that we can add in imagery as a background. And I'd say 99% of the time we show that is grabbing a ortho image, and since we've added it, we probably use our live maps tool so we can just grab it from Google Earth, Bing, or whatnot without having to worry about where we've stored our own high-res orthos, although we can bring in our own high-res orthos if we have them. But that idea of bringing in an image as a background is flexible, and I don't know if it gets used that much, but you can bring in any kind of image. So here I'll bring in a hillshade, just because it's one of those things that I think everyone will recognize. But it could be anything. It could be a wet area map, a heat map showing whatever you'd like, or it could be a canopy height model. So there's lots of flexibility in what you use that for. So once again, I'm going to add that in, and we'll see I do something wrong here. It'll just give me an opportunity to touch on our draw order. So I've added that in, and I put it in midway down our list, and it's blocking out that bird nest buffer that we've put in our topo. So there is a draw order, and if we want that image to be drawn first, we'll put it at the top of the list, and then everything else is going to be drawn on top of it afterwards. So there we are. Now, that's kind of a snapshot of different ways we can account for spatial data. Now let's just switch gears here and continue along. And well, let's look at how the design aspect can help us. I actually have to hit play, don't I? So the first thing I'm doing here is I'm just making it so I can see through that topo surface if I'm in cut with my road. So setting the transparency. And then I'll move my road over to where I think I should put it for a starting point, and I'm just going to click in my alignment similar to what I did last time. It's a planning phase, so I'm not going to get too bent out of shape about exacts, but I'm going to be reasonable. It doesn't take much extra time to say, well, that's a dumb spot to put a road. Let's just move it over 5 meters or 10 meters, etc. So I'm clicking in my horizontal, keeping a loose eye on my vertical. And my cross-section geometry, we want to meet whatever needs we have from our road use perspective. So I've got an 8-meter wide road in this case, which is appropriate for my needs. Now to make sure that road is aligned appropriately, I'm going to add my curves. So your curves are going to be associated with a design speed. So here I'm going to use a minimum curve radius of 100 meters, and that just equates to a 50 km/h design speed. You'll have to look up standards, but they're pretty reasonable to find, and it doesn't take long to know what you need. So I can set that as my default curve, and rather than going through and applying each one of those, I can just click apply default radius curve, and anywhere that default radius curve will fit, it gets added. And then I can just go in and move things around and make sure that, okay, everything that I had clicked in originally might not work perfectly. I'm gonna move this around to try and reduce some cut. And I'll add a curve at that other one. So it's still a little bit of playing around, and it's just kind of a matter that I might as well have a good plan. It's I'm not gonna get it within a millimeter right now, but I can at least make sure it makes sense. So I've got my horizontal close, and I'll go a different route than designing my vertical by hand, as I did last time. So rather than designing it by hand, I can use our optimizer to standardize the effort I put into this, and also give me an optimal solution to minimize my earthworks and material movement. So I'm just going to tell the software I want a minimum crest of 11, a minimum sag of 13. I'll add in a control point and tell the software to generate my vertical for me. And it'll take a moment to do that, but it'll be quicker than what I can do. And it'll give us a lower cost than what I can do. And it's going to spit out a number. So as designed based off of our cost parameters, it's telling me it's going to cost $58,000 to build. Well, if I want to explore other options, I can just do that. So I've duplicated my alignment and I can make adjustments. And in this case, I'll go a little different direction with it. So instead of trying in a whole new option, well, maybe from a planning purpose, it's valuable to know, well, do we want to weigh the economics of having a fast road and having reduced cycle time for what we're hauling out of there, or Do we have a slow road that's going to cost us less to build, and probably a smaller environmental impact? So I'm changing some curves to be a 30-kilometer-an-hour design standard, and I'll change my optimization to be a 30-kilometer-an-hour design standard. And we'll let that do its thing. And then the next part is, well, let's compare these two options. And I wasn't sure when I recorded this if I hit the right button there or not, so get to see something twice. So I'll let that do its optimization, and then we'll see the cost difference. And the cost is being populated just in the bottom right panel there. So total cost, and it's in thousands of dollars, and it's a function of whatever you input for unit costs. So I went from 58 down to 39 by reducing my design speed. Well, we can jump back and forth and compare those. The other thing we can do is, if aside from just costs, we can evaluate that based off quantifiable metrics. So I'll create a data table here. And usually from a costing standpoint, you'll be interested in your total cuts and fills and your aggregate requirements for surfacing. Now that's also a pretty good indication of how much construction effort there is, which has an environmental impact. But I've also added in planar areas for clearing areas and my seeding areas. So the lower the number for that, the less ground disturbance we're having. And then the seeding area, for example, so is going to be from our road edge to top of cut or bottom of fill. So immediately post construction, before we've had an opportunity to revegetate those slopes, that's where our opportunity to generate sediment comes from. So we can see that, okay, we can reduce our area and reduce our costs by going with that 30-kilometer-an-hour option. And last thing I'm going to show in the software here, and again, sorry for going so long, is the idea of the decommissioning aspect. So I'm not going to go into a ton of detail here. Decommissioning is one of those things that you already know where you're doing it. It's not so much figuring out the alignment, but there's value in planning it and designing it. So setting the goalposts for those that have to implement what you want to implement. And then from a quantifiable standpoint, knowing what you're up against for costs. So from a planning perspective, if you have a road that you know needs to be decommissioned afterwards, well, it's important to make sure you have enough money set aside to actually implement that decommissioning if needed. And this example that I have up here, I've got my cut and fill slopes tied to my delineated, it's an existing road rather than a designed road, but it's easier to do with a designed road. I've got those cut and fill slopes tied to my footprint, and I can plan to recontour that accordingly and get the same volumes and metrics that I would from a design. So with that, I will turn it over to Erin.
Awesome. Thank you, everybody. And first off, thank you for, staying with us late. We extended the webinar to be 90 minutes, and I think we need more than that. Anyways, a lot of great content. We saw both the sort of more theoretical side of things and then a bit of a demonstration in terms of how to apply it in software. I did just want to share a couple pieces while you're perhaps thinking up some questions you might want to ask us following, my little disclaimer here. But we do have 2 more webinars officially left in the series. Webinar number 1, Impacts and Considerations, is up on our YouTube page. If you missed it, feel free to find Softtree's YouTube page. You can check it out. And 2 weeks from today, we are going to be kind of, continuing to come down from 30,000 feet. We're going to be speaking at length about geometric road design, in particular cross-section geometry, materials and movement. And then part 4, which will happen 2 weeks following that, is going to be on drainage elements. And then the unofficial part 5, which is how to communicate all of this, is going to be on March the 31st. So you can sign up for those. If care, it'll be up at our softree.com website. Welcome, everybody's cameras back. The first question is going to actually be directed over, I believe, to Brian. So Brian, we've got a question here. It says, can someone discuss how predicted storm flows, for example, a 200-year storm, will change with climate change, and how should we be compensating?
So if anybody has an answer for that question, it's really complicated and we haven't figured it out yet. And there's been a lot of efforts that the ministry has undertaken to try and solve that question. We have a bunch of information on our website, as I mentioned earlier, that speaks to that. And there isn't any simple solution at this time. We are endeavoring to continue to evaluate that, and I don't have any sort of timeline on when we might solve that particular problem. It's been a primary focus for us for a number of years, recognizing that it is one of the biggest vulnerabilities to our road infrastructure, floods, and trying to predict that out. I mentioned in the piece that I did around the climate change, the coarseness of the modeling. A lot of the drainages that we're dealing with in a resource road context are relatively small compared to the major streams. There's been quite a bit of effort looking at analysis of major streams. So in BC, things like the Fraser. But the modeling is overly coarse that we can't get down to the scale of the smaller drainages. And we're working away trying to find surrogates of the climate data that will help us project out and provide guidance on how to develop more objectively and systematically design flood in the context of climate change. So sorry, I don't have a great answer.
Sorry, I forgot to press my unmute button. Awesome, thank you, Brian. We do have a couple questions here. They're kind of, a little bit more into the software side of things. So Matt, I'm gonna get you to tackle these ones.
Okay.
First question is, where is the hull cost coming from?
Oh, okay. So that is a user-defined cost. So in my ground types table, and I won't go into a ton of detail on this stuff, we have and we'll do again webinars just on material movement and costing. But in my ground types table, I can have different unit costs for my individual materials. So that's the handling cost. But from a movement cost standpoint, we account for that down here. So I've got categorized material movement costs. We've got our unit costs for either loading or hauling. And then that's going to drive the cost. So in this example, I used a 3-hull system. We could easily go with a 2-hull system if you didn't have 3 systems you want to account for. But yeah, there's a lot to that, and there's a lot of flexibility in the software to account for material movement, direction, and quality parameters. But that's a big answer that we don't have time for right now.
Yeah, and then kind of tied to that was a follow-up question, just how do we update our own costing model?
Oh, so I guess am I sharing my screen still?
You are still sharing your screen.
Excellent. Yeah, so that in that ground types table that I had open, you can change the unit cost to be whatever you'd like. So these are just the default values, but you can change it with local costs. And you can add new materials as well to account for whatever you want to include in there. And I will just mention it because I tend to talk more than I should in these things. But the costing methodology that the software uses is a different graphic than the mass haul, but you can export the data from that if you want to look at it, the same granularity that the software does. And we'll probably get into that a little bit, at least in our next webinar.
Great, thank you so much, Matt. Jeremy, the next question is for you. So in this case, it's kind of a follow-up to that same peak flow climate change projection question that Brian answered. However, yeah, they're wondering if consultants have other methods for climate change projections than the government does. And I'm gonna pass it to you.
Yeah, in the chat there, I sent a little note that, so we use kind of 4 or 5 methods, different methods when we estimate peak flows, and we have now an adjustment that we use to that, and so Erin will remind me, and I'll send out I'll send her a link to some of the resources that we use, but suffice to say, in a lot of times, it's coming down to a percentage increase, because when you look at the variation in the models that are out there for what's going to happen even over the next 50 years, there is a wide gap. They all say things are going to keep increasing, especially with peak flow, but there's a big variation. So anyways, yes, we do have some more. We'll put it on in the end there, but again, we're grasping at straws at this point, right? I think that one good, I mean, it's not that coarse, because of course we have what our estimations have been up to the last kind of 20 years, and then we've seen what's been happening, where we seem to have this decadal cycle of ugliness. The last 10 years have been not too bad, but the 10 before that were really bad. And so we're getting into kind of some bigger increases again now on the storm side. And so at least what we've been able to do is look at rainfall intensities and flows, and see how they actually changed based on the estimates that we had from before. And they're increasing for sure, especially with these short, steep streams that have very short time of concentrations. If you change the storm intensities a little bit, it makes a big difference, because some of these storms are lasting far longer than the time of concentration of these small streams. So that's the long answer to 10%. There's a couple of links.
Awesome. Yeah, and that's a really great reminder. So we are going to be sending out, as a part of our follow-up, and in the e-blast, there will be a link to a whole bunch of references and resources, and we will be sure to bug Jeremy to get those hydrology resources put into it. But yeah, a whole bunch of additionally climate change resources that Brian referenced will be included inside that resource.
Yeah, can I just make a comment? So Jeremy suggested that we're seeing increases everywhere as a consequence of climate change. There are some areas where drought may predominate, in which case we may see decreases in design floods.
Awesome. Okay, moving along, and yeah, if you have questions or if you want to ask us one out loud, don't be afraid. We'll just unmute you and be very nice. We've got a few more questions here, and they all look like they're heading towards Matt. So yeah, let's just kind of pick them off. This one's referencing one of the particular slides you showed during your presentation, Matt, and just looking to explain a little bit more about the cut slopes and what the differences are.
Yeah, so this is meant to be a graphic to touch on something that Jeremy introduced, but to also be a bit of a segue to what we'll talk about in our next episode in the series, and that's getting into our cross-section geometry, and part of that being cut and fill slope angles. So Jeremy mentioned that the example he used was that colluvium slope that's traveling up the hill. Different materials will stand at different angles of repose. So if you have a material that you can cut very steeply, you can reduce your footprint. And so here, the image to the left, that cut slope angle is 150%. And where if we go across that same hillside and we aren't able to cut at 150%, if we have to reduce that to 1.5 to 1 or 66%, well, I've got these really long cut slopes that are extending way up the hill. It's probably going to be a case where that's not practical to implement. So from a planning perspective, and that is our focus here, not necessarily the individual prescriptions that we can use to get around that, but from a planning perspective, that would be a, well, these hills look like they're maybe standing close to their angle of repose. If I cut into that, I'm going to expect to have to excavate a lot of material. So I would try and avoid that. I'd try and favor the gentle ground, explore other routes, and it may be explore other routes kind of at a micro level, but it could be explore drastically other routes where we come from a different valley or ridge. Hopefully that answers your question.
Looks like the next question is staying with you, Matt. So it said, yeah, can we import the center line as a shapefile instead of drawing it in the software? And
yeah,
if yes,
you can.
you do that as a batch of roads in various places? And if yes, how many road layouts can we optimize simultaneously? So many software questions.
All right. So you can bring in a shapefile. You can bring in I like land XMLs if you can get them, if you were talking about bringing out in alignments. The kind of a practical limitation that's kind of on the techie side of things is a shapefile is going to be a polyline. So with that, you've got your curves aren't true curves. So if you want proper curves, you're going to have to add those in. You can bring in, I don't think there's a limitation of how many you can bring in. It's just you'll bring them into the terrain file and then you'll add them rather than I chose center of terrain. I guess I didn't do that part today, but in my previous session, I just started with a single point. We could have brought in a feature and based that off of a terrain feature that came from a shapefile. From an optimization standpoint, you can do a bunch of vertical optimizations batched. Yeah, there's horizontal optimization in the software as well. That's not generative, and it takes a long time to solve. So that's not a practical solution to expect to batch horizontal optimizations. Hopefully that answers your question, and I don't have anything queued up to really go through all the nitty-gritty details there at the moment.
Awesome. Seeing as we are 28 minutes over, I just wanted to, take this opportunity to, thank our entire audience. I know we said it before. Thank you for staying up late. If you're particularly those of you in Europe, thanks for getting up early. New Zealand and Australia, we appreciate it. And we really look forward to seeing everyone in our, upcoming 2 webinars. Again, next one's in 2 weeks, same time. Slightly different link, and thank you for being here. And with that, I'm gonna shut it down since we're so over time. Thank you everybody again. We look forward to seeing you back.
Thanks everyone.